Okay, dear students, from the beginning we will discuss the problems of permutation today. Firstly, the first question is find the number of permutation of 5 different objects taken 3 at a time. It is very simple question. That is number n equal 5, r at a time, that r is 3. Required number of permutation is p53 or 5 factorial by 5 minus 3 factorial, that is 60 ways. And second number question, dear students, how many plates of vehicle consisting of 4 different digits can be made out of integers 4, 5, 6, 7, 8, 9? Here are not repeated numbers, but we have to fill up only 4 digits number. So 4 digit number, n is 6, r is 4, no repetition. That's why required number of permutation is p64, that is 6 factorial by 6 minus 4 factorial, that is 360 ways. Now question number 3, dear students. Yeah. 3 number question is 5 students enter a classroom in which there are 8 vacant seats. Find how many ways they can sit. 8 seats are there, n is 8, our student numbers is 5, then it will be they will be enter in 6720 ways. This is also similar question as A and B, or 1 and 2. Now moving to question number 4, dear students. In how many ways can 5 boys and 4 girls be arranged in a row so that the girls occupy the even places? Girls occupy the even places. There are 9 seats, 4 boys and 5 girls in a row. 1, 2, 3, 4, 5, 6, 7, 8, 9. Out of that, 1, 2, 3, 4, 5, 6, 7, 8, 9 seats, and in 9 seats 4 are even. Our condition is girls occupy 4 even places. There are 4 girls, and how many even places? 1, 2, 3, 4. So girls can be arranged in the 4 factorial, means p 4p4 ways, that is 4 factorial ways, and boys can be arranged in 5 different ways, 5 factorial ways, and total number of arrangement is 4 factorial times 5 factorial, that is 2880. As girls are in even place, boys are in odd place, they can be arranged in number 4 even numbers, 4 girls, 5 odd numbers, 5 boys. That's why 4 factorial times 5 factorial, that is 2880. Now moving to the next question, question number 5, dear students. Question number 5 is this: in how many ways can 4 boys, 3 girls be seated in a row having 7 seats? Condition first is they may sit anywhere. Condition second, the boys and girls must alternate. And third is all 3 girls are together. And 4 is no go 2 girls are together. This is a question. So we have to think there are 7 boys and 3 girls. In total there are 7 students or 7 people, and there are 7 seats, so they can be arranged in 7p7, that is 7 factorial ways, if they can sit anywhere, which is 4050 ways. First part. And second part is the boys and girls must alternate. So 4 boys out of 1, 2, 3, 4, 5, 6, 7 seats, 4 boys can be seated in 4p4 ways, and 3 girls can be placed in alternate seats in 3p3 ways. So they can arrange in the 3 factorial times 4 factorial ways, which is 144. In this case they may sit in an alternative position. Boys and girls number and their position are alternate position are equal. Now moving to third number question, third part, that is what is the third part? All 3 girls are together. All 3 girls are together. In this case, taking 3 girls as one. 3 girls is the group is taking as one, and here are 4 boys. In total there are 5 people which can be seated in 5p5 ways, but 3 girls themselves can be arranged in 3 different ways. Because they are not the same, they can be arranged again, they can be arranged in 3 different ways. So the total number of permutation is 5 factorial times 3 factorial, that is 720 ways. And next question is, the last question is, no two girls are together. The question is, no two girls are together. That can be done by this way. We can solve that by this diagram, will be better to understand. Four boys are placed in this way. First we place 4 boys in 4 seats in 4 people ways, and there are 5 alternative places for 3 girls, either here, 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 here and here. The girls can be placed in 5 different places, but there are only 3 girls, so that can be arranged into 5p3 ways, that is 60 ways, and the total number of arrangement is 4 factorial times 60 is 1440. 1440 is the required number. 5 places, 3 girls can be arranged into 5p3 ways, and 4 boys in 4 factorial or 4p4 ways. The total answer is, the required number of permutation is 1440. Now next, number 6. In how many ways can 6 students be seated in a row of 6 places if 2 students insist on sitting next to each other? So in this case also, 2 students fixed a position plus remaining 4 students. In total there are 5 arrangements which can be arranged into 5 different ways, but the 2 students are different, so they can be arranged into 2 different ways, and the total arrangement or the permutation is 5 factorial times 2 factorials equal to 240 ways. Now next question is question number 7, dear students. In question number 7, 6 different books are arranged on a bookshelf. Find the number of different ways in which 2 particular books are always together and not together. 2 books are always together. How many books? There are 6 books, out of them 2 always together. That 2 books represent 1 plus remaining 4 equal to, here also 5 books. 5 books can be arranged into 5 different ways, 5 factorial ways, and 2 books themselves can be arranged 2 different ways, that is 5 factorial times 2 factorial, that is 240. And always not together can be solved by, the second part is about not together. How to find that is not together? Look at here, dear students. 6 books can be arranged anywhere, that is 6 factorial ways, and 2 particular books are not together. Then required number of arrangement means total arrangement minus together. When they are together, the permutation is 240, which is subtracted from the total arrangement, and in 480 ways not together will be obtained. 240, they are together, 2 books are together, and total arrangement 6 factorial ways, 6 book without considering together or not, that is 720 ways, and from 720 ways that together is subtracted, then we obtain 480 ways. This is the condition. And the next question number 8, dear students. In how many ways can 4 red beads, 5 white beads and 3 blue beads be arranged in a row? This is the case of repetition. That's why total is 12 beads and 4 repeated, red in 4, white in 5 and another in 3. That's why 4 factorial, 5 factorial, 3 factorial. This is the case of repeated objects. Now question number 9. Question number 9 is, how many numbers of 6 digits can be formed with the digit 2, 3, 2, 1, 3, 3? So 232133. So total number of digits are 6, and 3 3 are here and 2 twos are here. Here is no 0. In case of 1, in every place we can put this digits. That's why total number of arrangement is n factorial by p factorial times q factorial, 6 factorial by 3 2 factorial, that is 60 ways. But the same question can be done, if the question is changed slightly, then we can show, I can show you. For example, how many numbers of 6 digits can be from with the digit 232033? Here now 0, if here is 0, we cannot place 0 at the sixth place or the uh, first year. In this place we cannot put. If we put 0, it won't be 6 digits number. 1 2 3 4 5 6 digit number, so we cannot place here 0. So total number of digit is 6, number of 3p is 3, 2's is 2. So 60 ways in total we can arrange this. But dear students, uh, the number, our condition is, since the number don't begin with 0, there are only 5 digits. Here first digit चाहिँ 0 बाट start हुन पाउँदैन. At 5 digits, so these 5 digits can be arranged in 5 factorial by 3 and 2 are repeated in same ways. It is 10 ways. So therefore required number of 6 digits. In this way we cannot arrange. The total is 60 minus this 10 is 50 ways, or we can do by another process also. First in 5 and other process. Yeah, first can be arranged in 5 and another is 5 times 5 factorial ways. 5 and 5 factorial ways will be 50. Now moving to question number 11, dear students. Question number 11 is, in how many ways can 4 arts student and 4 science student be arranged in a round table? This is circular permutation we are discussing. They may sit anywhere and they sit alternatively. This is the question. So first, they may sit anywhere. It is very easier question, because there are 8 students. Out of 8 students, 1 we have to fix in circular arrangement. So 8 minus 1 factorial wise, that is 7 factorial wise, which is 405040 wise. First part is completed, and they can sit alternatively. In this case, 4 arts and 4 science students are here. So in a circular arrangement we have to fix. Suppose we fixed a science student. If we fix in the circular arrangement, here is science student. Now there are 3 if we fix science student, then science student can be arranged in 4 minus 1, that is 3 different ways. Then arts student we can be arranged in alternative form, that is in 4 different ways, and the product 3 different times 4 different ways is the required answer for this question, which is 144 ways. Because if we fix one, then they will provide circular, they will, then after we can arrange in like in a linear form, and we'll get this answer. Now moving to question number 12, dear students. In question number 12, the Prime Minister of 8 South Asian countries met together to discuss a problem. In how many ways can they sit around a table? This is also the circular permutation. If Prime Minister of India and Pakistan don't sit together, सँगै बस्दैनन् भने what will be the condition? Okay, it can be solved by this way, dear students. Our condition is 8 countries are there. They need to arrange in the round table. That's why it can be arranged into 8 minus 1, that is 7 factor is 4050 ways. And second part is, if Indian and Pakistan both sit together, they are supposed to be 1, and total arrangement in round table will be 7 minus 1 will be 6. Again, 2 prime minister can be arranged into 2 different ways. So the permutation of second part is 6 factorial times 2 factorial, which is 1440. And our condition is finally both prime ministers are not sitting together, that is this minus this 1440 4050, that is they can they can both prime earners sit together is 5040 minus 1440, that is 3600 ways. Now moving to 13 number question, dear students, in how many ways can 5 gentlemen and 2 ladies be arranged at a round table? This is also circular permutation. Sit together or separated. Sit together total 7 minus 1 6 ways. You understand this? And 2 ladies sit together, required number of arrangement is here also 6. 5 gentlemen and plus 1, there will be total 6. 6 minus 1 will be, that is 5 different ways. Again 2 ladies can be arranged into 2 different ways, that is 240 ways. If 2 ladies are separated, then the required number is 720 minus 240, that is 480 ways. We can arrange them into 480 ways. Now question number 14, dear students. Question number 14 is like this. In how many ways can 8 people be seated in a round? This is also circular permutation. If 2 people in sitting next to each other, so that 2 people represent 1. 2 people in one sitting next to each other, then we will have no concept. 2 people is 1, and there are 7 places to be filled up. The required number is 7 minus 1 is 6 factorial, that is, and they can be arranged into 2 different ways. That's why 6 factorial times 2 factorial is 1440 ways. Yes, now moving to 15 number question, dear students. How many ways can 7 person can be seated around a table if 3 person insist on sitting next to each other? Like previous condition, 3 represent 1 and remaining 1 2 3 4, total is 5. And in circular permutation we have to subtract 1, that's why it becomes 3. And 3 can be arranged into 3 factorial ways or 3p3 ways, and 144 ways is the answer by the calculation. Now question number 16, dear students. Question number 16 is, how many ways can 7 different color beads be made into the bracelet? That is, here number of color is 7, color beads is 7. This is arrangement is n minus 1 because this is circular permutation, but anti-clockwise and clockwise arrangement is same, that's why dividing by 2, which is 360 ways for this. Now moving to the next part, 17 number question. 17 number question is, this is like a power. How many ways can 4 letters be posted in 6 letter box? 4 letter in 6 box, 4 letters in all, in first or in second, all in third, all in fourth. That's why it raised the power 4. In 1 to 96 ways we can arrange them. Question number 18. Question number 18 is important question, maybe. How many even numbers of 3 digits can be formed when repetition of digit is allowed? Here repetition is allowed, even numbers of 3 digits. Okay, so dear students, it is important question. Let's think. We have 0 to 9 digits. There are 10 digits starting from 0 to 9. So we have to make even numbers of 3 digits. 1 2 3, 3 digits number but even. So this unit place can be arranged into 5 different ways, as we can put 0 2 4 6 and 8. So first unit place can be arranged into 5 different ways, and repetition is allowed. So in this second or a 10th place, it can be arranged into 10 different ways. Every number can be kept here, so it can be arranged into 10 different ways. And the third is in 9 different ways, because 0 should not be there. It is very important question. In that sense, dear student, the total arrangement is 450. I want to repeat you again. In 100 place, we should not put 0. So there we can arrange 9 different numbers. In tens place, all numbers can be kept. And then unit place number, only even numbers. To make even number, 0, 2, 4, 6 and 8 can be kept. So by the laws of multiplication principle of counting, 9 times 10 5s are 450 ways we can arrange them, or we can make even number of 3 digits by using this condition if repetition of digit is allowed. Now moving to the next part, question number 19, dear students. Question number 19 is, in how many ways can 3 prizes be distributed among 4 students? So each student may receive any number of prizes. So this is also power. 4 students, 3 prizes, 4 to the power 3, that is n to the power r formula, you know that. So that's why 64 ways. And next question is 20 number question. 20 number question is very good question, I think. In how many ways can 6 students can be arranged around a table? This is around a table if best and worst student never come together. This is also not difficult question. Similar questions we have discussed in previous question pattern also. 6 students can be arranged in a round table equal to 5 different ways. No doubt for this. And if best and worst come together, and there are 5 arrangement, 5 minus 1 is 4 different ways, but again best and worst can be arranged into 2 different ways, so their product is 4 factorial times 2 factorial. But our condition is never come, that's why from the total we have to subtract if they come together. 5 factorial minus 4 times 2, 4 factorial minus times 2 factorial, 72 ways we can arrange this. It is also good question, dear students. Yeah, now moving to the next part, dear students. 21 number question. 21 number question is this. Okay, dear students, question number 21 is like this. How many different words can be formed from the letters of the word ordinate, ordinate, so that the vowels occupy the odd place? Question number 1. Beginning with O, that is question number 2. And beginning with O and do not end with E. There are 3 conditions, dear students. So let me count. The word is ordinate. There are 1 2 3 4 5 6 7 8. There are 8 letters. Okay, out of 8 letters, 4 are vowels and 4 are consonants. O is vowel, I is vowel, A is vowel, and E is vowel, and others are R, D, N, T are consonant. First be clear about the structure of the word. So in the word ordinate, there are 4 vowels, 4 consonant, and 4 odd position and 4 even position, because 1 2 3 4 5 6 7 8, 1 2 3 4 5 6 7 8, 1 2 3 4, these are even place, remaining are odd place. So what is the condition? So that the vowels occupy the odd place. A vowel letter can be arranged 4 different, because there are 4 odd position and 4 odd letters. Vowel letters, they can be arranged 4 factorial ways or 4p4 ways, and consonants letter can be arranged in the same order or same way, that is 4 different way. And then the total arrangement is 4 factorial times 4 factorial, which is 5 7 6. First part is that. First part is that. And the second part is, dear students, what is second part? Second condition given here is beginning with O बाटै सुरु हुने. That's so beginning with O, dear students, we have to consider second part, beginning with O. For that, fixed O in the first place, and remaining are 7 letters can be arranged into 7 different ways, because this is not the circular permutation. So 5040 ways is the required condition. And now the third condition is beginning with O and do not end at E. So in this case, it is quite interesting question. In this case, dear students, you can see we have to arrange. Here you can see, firstly beginning with O and ending with E. Beginning with O and ending with E, we have to find the arrangement. And before that, total arrangement, the number of arrangement of the word beginning with O is 7 factorial, that is 4050. First part is total, beginning with O only we have to find. Then beginning with O and ending with A we have to find. Number of arrangement word ordinate beginning with O and ending with E is 6 factorial, because 2 are fixed, remaining are 6 later, that is 728. But our requirement is beginning with O is okay, but do not end with E. That's why you have to subtract beginning with O, and ending with E from beginning with O only. That's why number of arrangement beginning with O and do not end with E is 5040 minus 720. This is 4320. Again, I want to highlight this. Firstly, beginning with O, that are 7 factorial ways. Beginning with O and ending with E, that is 6 factorial ways. But our condition is beginning with O but not ending with E. That's why from this to this, 7 factorial to 6 factorial we have subtract to obtain the required condition. Okay, now moving to next question. It is important question for examination point of view, dear students. Please focus in this question. Now moving to the next question, that is question number 22 in my part. So that the number of ways in which letter of the word arrange, A-R-R-A-N-G, arrange, can be arranged so that R's do not come together is 900. The answer is given here, which is 900. But the condition is R do not come together. Okay. Now let's see what is here. R do not come together. So first of all, dear students, in the word arrange, there are 7 letters. No doubt, 1, 2, 3, 4, 5, 6, 7, which consist of 2 R's and 2 A's. Repetition, 2 R and 2 A's. So all the rest are distinct. Therefore, total number of arrangement, 7 factorial by 2 factorial, 2 factorial, that is 1260 ways. No doubt it is okay. Now, we have to find this is what arrangement what from the direct 7 letters, 2 twos are repeated, it is the way of arrangement. And but if two R's come together, both may be considered as a single letter. Therefore, the number of arrangement in which R's come together is 6 factorial by 2 factorial. Why? 2 R's is a single, then there are other 5, in total 6. Out of that 6 total, we are not counting R, but we have to count A also. That's why 2 factorial we have divided, which is 360. Because there are 6 arrangement, out of that A is repeated, while considering two R's come together. And the next part is and sometimes 2R can be arranged into 2, but that is the same, that's why we are not doing that, just dividing 6 factorial by 2 factorial. If they are distinct, again by two different ways they can be arranged, but they are the same, so there is no possibility for that, you have to understand. So this is total number of arrangement, this is when R's come together arrangement. That's for our requirements R do not come together is 1260 minus 360, which is 900 different ways. This is also another important question, dear students, you have to consider. Now question number 23, my dear students. Question number 23 is also important question. So that the number of arrangement that can be made from the letters of origin, Orion, so that two consonant may not come together is 36. Two consonant may not come together. Okay. How many letters are there? 1, 2, 3, 4, 5. Consist two words and rest are distinct. We can find the total arrangement 5 factorial by 2 factorial, that is 60 words. No doubt for this. But if two consonant comes together, there are two may be considered as one. So total is 4. 4 factorial by two vowels are there. That's why it can be arranged to 12 different ways. But two consonant can interchange their position is two different ways because they are not same here. In previous question they are the same letters, so we have not multiplied that, but here they are not the same letter, different letters. That's why we have to multiply 12 into 2. That's why it is 24 different ways. Now from 60 total, from 60 we have to subtract 24 to obtain which two consonant may not come together. In this way we can solve this question. Now question number 24, dear students. Question number 24, let me read out. In how many ways the word computer be arranged so that all vowels are always together? First condition. The vowels may occupy only odd position, second condition, and the relative position of vowels and consonant are not changed. This is the question number 24.
So
Okay, dear students, question number 24 is like this. Again, I want to repeat. In how many ways the word computer be arranged so that I, all vowels are always together. The vowels may occupy only odd position. Third, the relative position of vowels and consonant are not changed. Third condition is that. Okay, for this, how many letters are there? 1, 2, 3, 4, 5, 6, 7, 8 letters are there. And first condition is all vowels are together. What are the vowels? O, E, U, E. Three vowels are there. All different vowels are there. Right? If vowels are three is supposed by one, then other remaining five letters, in total six letters are there. Six letters can be arranged in 6p6, that is 6 factorial ways. And but these vowel are different, that's why they can be arranged into factorial ways. The total number of arrangement is 6 factorial times 3 factorial, that is 4320 ways. I think you understand this, you know. 6 and again 3. And the second part, dear students, what is the second part? Let me highlight. The second part is the vowels may occupy only odd position. Vowel in odd position. The vowel may occupy only odd position. The question is, there are 2 points here. Three vowels, 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. In out of 8 seats, how many are odd seats? 1 seat, 2 seats, 3 seats, and 4 seats. But vowels occupied odd position. Out of 4 seats, they can arrange in only three vowels can be arranged in 4 seats. That's why first may be in 4 ways, second may be in 3 ways, and third may be 2 ways. This is for the vowels. Yeah, because there are 4 seats, 3 are vowels. That's why they can be arranged into 4 times 3 times 2 ways. You know that. And consonant, but there are 5 consonant, they can be arranged 5 different ways. For the consonant, they have any places, 5 consonant occupied in 5 position, so it can be arranged. Total number of arranges 5 factorial times 4 times 3 times 2, 2880 is the required answer. Now moving to the next part, dear students, moving to the next part. And third is, what is the third condition? The relative position of vowels and consonant are not changed. The relative position are not changed. That means, uh, okay, yes. Three vowels can be arranged three different ways, five consonant can be arranged five different ways, though their position not changed. That is 3 factorial times 5 factorial wise. Okay, now question number 25, dear student. This is also important question, very important question. Find the number of arrangement of the letters of the word laptop. The vowels may never be separated, comes together. All consonant may not be together. They always begin with L and end with T, and they do not begin with L but always end with T. That is very important question, dear students. Let's discuss this very sincerely. Laptop. How many letters are there? 1, 2, 3, 4, 5, 6. 6 letters are there. And in these 6 letters, two vowels, A and O, are there. A and O are vowels and 4 are consonant. Since two vowels must be together, so we consider them as single. Vowels सँगै हो भने 1 consider, then remaining 4, there were 5. And it can be arranged into 5 factorial ways, but among the consonant P is repeated, that's why it can be arranged into 5 factorial by 2 factorial ways. As P is repeated twice, it can be arranged into 60 ways. Again, the two vowels are not same, that's why two vowels can be arranged into two different ways. Okay, two different ways. That's why the required answer is 2 times 60, that is 120 ways for the first, that is the vowels may never be separated or comes together. First part is that. Now moving to second part, dear students, the question for second part is what is given in second part, that is all consonant may not be together. All consonant may not be together, that is the question. So in this case, dear students, I want to make you clear the required number of arrangement is total arrangement minus arrangement in which consonant comes together, do not come together. That's why the total arrangement is 6 factorial by 2 factorial. First one is 6 factorial by 2 factorial, it is clear. And but consonant, what are the consonant? The word is LAPTOP. The word is LAPTOP. Two are vowels, LPTP. LPTP are consonant. Now we have to arrange consonant comes together. When we have to find consonant do not come together, but here consonant comes together, we have to subtract. So here you can see 4 digits can be arranged into 4 factorial by 2 factorial ways. Yeah, 4 factorial by 2 factorial ways, that's why it is 4 factorial by 2 factorial ways. But there are, yes, if these 3 consonants comes together, 4 consonants supposed by 1, 4 consonants supposed by 1 comes together plus remaining 2 vowels, there are 3, they can be arranged into 3 different ways. म अझै तपाईहरुलाई बुझाउँछु. टोटल 6 लेटरबाट दुईटा पी रिपिटेड भएको हुनाले यो टोटल अरेन्जमेन्ट भयो. अब दोस्रो सेकेन्डमा चाहिँ कन्सोनेन्ट कम टुगेदर आउने सब्ट्र्याक्ट गर्यो भने कन्सोनेन्ट टुगेदर नआउने थाहा हुन्छ. त्यसकारण कन्सोनेन्ट सँगै आयो भने चारवटा कन्सोनेन्टले के गर्यो, 1 पोजिसन काम गर्यो प्लस रिमेनिङ 2 भवेल्स भन्छन् त्यहाँ 3 अरेन्जमेन्ट भयो. यो 3 फ्याक्टोरियल वाइज. फेरि हामी 4 वटा कन्सेनम एलपीटीपी को पनि अरेन्जमेन्ट हेर्नु पर्यो. एलपीटीपी को अरेन्जमेन्ट चाहिँ के भयो भन्दा 4 फ्याक्टोरियल बाइ पी रिपिटेड भएको हुनाले 2 फ्याक्टोरियल वाइज. द्याट्स वाइ इट इज 360 - 72, द्याट इज 222. 288 voice यो टोटलबाट कन्सोनेन्ट कम्स टुगेदर आउने एरेन्जमेन्ट सब्ट्र्याक्ट गरेपछि कन्सोनेन्ट टुगेदर नआउने एरेन्जमेन्ट चाहिँ फाइन्ड आउट गर्न सकिँदो रहेछ दिस इज द अन्डरस्ट्यान्डिङ फर दिस क्वेसन है नाउ सेकेन्ड पार्ट एन्ड थर्ड पार्ट सी पार्टमा जाउँ हामी थर्ड पार्टमा the third part, let me check one word in the third condition. Third condition, C is begin with L and end with T. अब T L बाट सुरु हुने र T बाट के हुने अन्तिम हुने. In this case, here we can see we fixed L in the first position, T in the last position. There are 4 letters. They are A, P, O, P. अब A, P, O, P भएपछि त 4 letters and दुईटा चाहिँ P repeated छ हेर्नुहोस् 2 factorial 12 वाइज मलाई लाग्छ यो चाहिँ इजी छ दुईटा फर्स्ट र लास्टमा फिक्स्ड भयो बाँकी 4 वटा बट दुईटा पी रिपिटेड भएर डिभाइड गर्यो इट इज इजी टु अन्डरस्ट्यान्ड यो गाह्रो छैन बट द final point of this question is they do not begin with L but always end with T. T बाट सकिने L बाट चाहिँ स्टार्ट नहुने अब यसमा पनि हामीले ट्रिक युज गर्नुपर्छ गाह्रो छैन हामीले टी लाई लास्ट पोजिसन फिक्स्ड गर्यो भने त्यहाँ 5 वटा लेटर हुन्छ 5 वटा लेटर मध्ये पी 2 टाइम्स रिपिटेड भएको हुनाले ल्याप अप भयो नि त टी छुट्यो एलएपीओपी भयो 5 डिजिट्स इन्टु डिफरेन्ट हो यो बुझ्नुहुन्छ अब फेरि एरेन्जमेन्ट दैट बिगिन्स विथ यल बाट स्टार्ट हुने सब्ट्र्याक्ट गर्यो भने यल बाट टी मा एन्ड हुने र यल बाट स्टार्ट हुने सब्ट्र्याक्ट गरियो भने टोटल रिक्वायर्ड एरेन्जमेन्टबाट टी लाई लास्टमा फिक्स्ड गर्यो टी मा एन्ड हुने र यल मा स्टार्ट नहुने निकाल्दा टी मा एन्ड हुनेको प्रोबेबिलिटी एरेन्जमेन्टबाट टी मा एन्ड हुने र यल बाट स्टार्ट हुने सब्ट्र्याक्ट गर्यो भने यल बाट स्टार्ट नहुने बट टी मा एन्ड हुनेको आउँछ दैट्स व्हाई यहाँ एलएपी अब यल बाट स्टार्ट नहुने यल बाट स्टार्ट हुने टी मा एन्ड हुने सब्ट्र्याक्ट गर्नु पर्यो दैट इज 4 फ्याक्टोरियल बाइ एपीओपी हुन्छ दैट इज 4 फ्याक्टोरियल 2 फ्याक्टोरियल 48 वेजमा चाहिँ यो सकिन्छ अरेन्जमेन्ट गर्न सकिन्छ दैट क्यान बी डन दैट वे नाउ मुभिङ टु द नेक्स्ट क्वेसन डियर स्टुडेन्ट दिस इज द लास्ट क्वेसन अफ दिस च्याप्टर among the very important question how many different words can be formed with all the letters of the word internet each word is to begin with vowel and each word is to end with consonant b v v I m p question is this very interesting internet if each word is to begin with vowel and each word is to begin with consonant each word is to begin with vowel and each word is to end with consonant not begin end with consonant for second part but first part is this so dear students I have two methods here I have expressed in a very different way the word begin first case first the case first each word is to begin with vowel yeah the word begins with I then there are 7 letters contains 2 n 2 e 2 t and 1 r so the required number of arrangement is 630 हेर्नुस् है इन्टरनेट छ नि INTERNET 1 2 3 4 5 6 7 8 वटा वर्डहरु छ देयर आर 8 लेटर्स हैन 8 लेटर्स मध्ये आई बाट स्टार्ट हुने each word is between vowel vowel मा के छन् भोकेबलहरु के छन् I छ E छ I र E छ हो भोवेलहरु I र E दुईटा छन् यिनीहरुबाट स्टार्ट हुँदा I बाट स्टार्ट भयो भने के हुन्छ I बाट स्टार्ट हुँदा त्यहाँ 7 वटा लेटर्सहरु हुन्छन् I त फिक्स्ड भइहाल्यो 7 वटा लेटर्स छन् त्यो 7 मध्ये N दुईटा छन् E दुईटा छन् T दुईटा छ र R एउटा छ भन्छन् त्यो अरेन्जमेन्ट चाहिँ 7 फ्याक्टोरियल बाइ 2 factorial 2 factorial 2 factorial that is 630 words by I think I make you clear here अब सेकेन्ड मा जानुहोस् सेकेन्ड केस मा जाउँ सेकेन्ड केस भनेको यो ए अन्तर्गतको केस फर्स्ट र सेकेन्ड अब अर्को भोवेल ई बाट स्टार्ट गर्यो भने ई बाट स्टार्ट गर्यो भने पनि त्यहाँ के हुन्छन् 7 लेटरै हुन्छन् दुईटा एन हुन्छन् दुईटा टी हुन्छन् एउटा ई हुन्छ एउटा आई हुन्छ एउटा आर हुन्छ टोटल नम्बर अफ अरेन्जमेन्ट कति हुन्छ 7 फ्याक्टोरियल बाइ 2 फ्याक्टोरियल टाइम्स 2 फ्याक्टोरियल 1260 हुन्छ all numbers that start with vowel e र I बाटै स्टार्ट हुने दुईटै कन्डिसनलाई एड गर्यो भने 1890 is the required ways of arrangement. This condition is the solution of first part. Or it can be done by another way, dear students. अब यसलाई हामी अर्को तरिकाबाट पनि हेरौँ. यो चाहिँ बहुत महत्त्वपूर्ण क्वेशन हो. यसलाई हामी नेक्स्ट वेले can we see, let's see how we have A part कै नेफ्ट भनेको there are 8 letters 2n 2e 2t. Now the first letter can be chosen in 3 different ways. Remaining places can fill in the 8 minus 1 ways. Yes, 3 times 7 factorial by 2 factorial 2 factorial 2 factorial. This is यो कसरी 3 ways भयो त नि भन्दा हाम्रो के छ त्यहाँ दुईटा ई छ एउटा आई छ इन्टरनेट INTERNET इन्टरनेट तीनटा भवेल्सहरु छ 3 डिफरेन्ट वेजमा चुज गर्न सकिन्छ त्यसपछि remaining place can be filled up in 8 minus 1 ways, that is 7. एउटा अगाडि फिक्स्ड हुन्छ नि त बाँकीलाई त 7 वेजमा फर्स्ट लेटर एउटा मात्रै फिक्स्ड हुने भयो अरु त फेरि 7 वटा त बाँकी नै रहन्छ एउटा अगाडि सबट्र्याक्ट गरेपछि that is 7 factorial by अनि फेरि त्यसमा के छ भन्दा तीनटा रिपिटेड छ repeated भएको हुनाले 2 factorial times 2 factorial times 2 factorials, then it can be done in this way. Now I think upper is better than this to understand. Now moving to B part, dear student. B part is here are 8 letters 2n 2e 2t. Now the last letter can be chosen in 5 ways and remaining place can be filled up in 8 minus ways. 5 times 7 factorial by these ways like previous one. 8 letters ma duita n duita e duita t cha. It can be arranged in this way and 315 and first in consonant are 5, that's why they are in 5 different ways. Now the last question is the last problem is or it can be done by another way I have shown first. First case the word ends with n. n बाट अन्तिम हुने निकाल्नुहोस् तपाई. n बाट end भयो भने 7 factorial by 2n 2 times 2 factorial times 2 factorial के भन्दा दुईटा 2e हुन्छ 2t त्यहाँ हुन्छ. अनि सेकेन्ड मा तपाई जानुहोस् t बाट n हुँदाको कन्डिसन यो हुन्छ. अनि फेरि तपाई नेक्स्ट मा जानुहोस् अनि तपाई फेरि नेक्स्ट मा जानुहोस् 5 वटा छ नि त एन्ड हुने हैन. फेरि केस थर्ड मा जानुहोस् r बाट एन्ड हुनेको अवस्थामा यो हुन्छ. यो तीनटै जोड्नुहोस् किन भन्दा दुईटा त रिपिटेड छ अनि 31550 वेजमा चाहिँ हामी के गर्न सक्छौं कम्प्लिट गर्न सक्छौं. I hope you understand the solution of all the 26 important questions.